Good morning, everybody. Afternoon, I guess, technically. Today, we're getting started with the semester, and this class is thermodynamics. So today, we're going to take a little bit of time and go over the procedures for this class and how you guys are going to become amazingly successful in thermodynamics. So our class page here on our Moodle site is for two different sections. One N section is fully online, which we have one or two students who are fully online. And then the H section is hybrid, which means we meet once a week and we do work independently or come search me out for help on the other 2 days. So it's really important to note that with a hybrid class like this, all of the content is on the Moodle page. So that means when we have lectures on Tuesdays, I'm not going to say, okay, now let's turn to chapter 2 and do these problems. It's a guided experience for you, and the point or the way that it works it's called a flipped classroom is basically you watch videos and do the work outside of class and then bring problems and concerns to me, and we'll jump in at the point where you need my help or where you just need clarification or you just want to talk about something, like something strikes you as like, this is so weird and freaky, which thermo gets into a little bit of freaky stuff sometimes, so I kind of like that. But and you may as well. But it's also a point where I always tell people that with engineers tend to fall early on into one of two categories. They either like things that sit still or they like things that move. And later on, right now, we're just getting an entree into this. You start finding out if you like things that flow, which is a certain kind of a movement. And thermodynamics is really all about things that flow. So you'll see, for example, there's really no way to draw a free body diagram in thermo. You draw a system diagram, which is equally as rigorous, but it has a little bit different philosophical stuff. But some of the points of thermodynamics remain basically conservation equations, but the second law of thermodynamics, when we express it mathematically, which we're doing after midterm, actually is the first great law of the physical sciences that is not a conservation equation, which means this does not equal this, or you have to put in a dummy term to make everything equal each other. So that's kind of a cool thing too. It just tells you the universe is an interesting, complicated place, right? So basically, I'm going to replace this tab, the All Class Intro for Spring 25, with All Class Intro for Spring 26, which would be on my lecture today. And then I generally just put up little things that I find to be interesting about thermodynamics. And for a while, I was really toying with this idea that everything in human development in terms of energy transfer has been about new and improved ways to make steam. And so there's a lot of cartoons on here that just talk about making steam. So I may change that at some point, but for now, a lot of my cartoons have to do with that. Having said that, then let's take a look at a couple of different things, and we'll start, of course, with the syllabus. And here on the syllabus, like we say, we have asynchronous or one meeting plus Moodle content. You all know my name, Astrid Northrup. You know where my office is. Just right across the hallway. And anytime that you need to zoom into class, for example, if you're just not here, but you really want to talk on our Tuesday together, use that Zoom link, which is my personal meeting room, which is one I use all the time. And my office hours are whenever you want to meet with me, pretty much. So if you go to calendly.com, you can always schedule office hours. The best way to get a hold of me is via email or text. And I always tell people, I actually put this on my voicemail message. Please don't leave me a voicemail, just text me, because I do not pick up my voicemail. I'll have no idea. I'll have no idea if you called me or not. So please send me a text or send me an email and I'll get back to you right away. So what is thermodynamics? Well, thermodynamics is the science of heat and energy. And heat is actually a form of energy. So it's really just the science of energy and what energy does. So another way to describe it is that it is the study of energy and entropy. Energy talks about an amount that changes form or passes through a barrier, and entropy talks about the direction in which it occurs. Okay, so what I mean by that is a simple example. If I have a glass of iced tea and I put it here on the desk, the first thing that's going to happen is the ice will start to melt, and then after the ice melts, if the room is warmer than the cold liquid, the liquid will start to warm up. Okay, but there's a process for how that works. The ice will melt first, the beverage will heat up second, right? And what if I put that glass of water on another table, or that glass of iced tea, and I expected the ice to freeze and the beverage to cool down? Well, what would make that happen?
The room was below freezing.
That's exactly right. If the room was below freezing, something of that effect would happen. So that's the idea of entropy. Things happen in a certain direction, and we can't we can't violate that without putting energy into a system. Another example, if I have a coffee cup here and I drop it on the floor and it breaks into a whole bunch of pieces, what are the chances that I could take those pieces and throw them back up on the table and they would reassemble themselves into a coffee cup? Very low, but not zero. Statistically, very low, but not zero. And that's also the study of entropy. The form on the floor in a bunch of pieces is more, they like to say random. It's kind of a common word, but really likely is the answer. There's only one way that it can be a coffee cup. So there's one way that it can be a coffee cup. There's a whole bunch of ways it can be a bunch of broken pieces on the floor. So there are many more states of likelihood that it's going to be broken than it's going to be put together. So when we talk about entropy, that would be another direction. So if we did have a bunch of pieces of the coffee cup broken on the floor and we wanted to reassemble it into a coffee cup sitting on the table, we would have to put energy into it. We have to take energy, take the pieces, put them up there. We have to take energy to match the pieces together, probably a little bit of glue, and get everything put together, but it doesn't happen for free. Okay, so that's kind of how entropy works. And we're going to quantify that mathematically in the time that we have together. The goals are to gain factual knowledge and terminology of engineering thermodynamics, to understand phase behavior, state functions, and to solve problems in thermodynamics. Okay, so all of those things, if you're familiar with them a little bit, maybe from chemistry, you can use that information from this point forward, and if you're not, you're going to learn about them. The other thing that really becomes an issue in this course is the units that we use. As you know, most of the world uses SI units or metric units, and the United States uses something else, right? I mean, you can call it the US customary system is what I prefer to call it, because it arose from custom, right? It's like the old joke. It's not really a joke, but the old thing is like, what is the length of a foot? Well, it was some ruler's foot. And then you get another ruler and the foot is a different length, or something like this. But it doesn't really have anything to do with the world or powers of 10 or multiplication. So in units of work and energy and power and the other quantities that we measure in thermodynamics, the units you have to understand a whole bunch of different units. So the first piece of warning I wish to give you is there are books out here for people not like us. This is not for us. This book, Thermodynamics, An Engineering Approach, has the right author, Eunice Changel. But if you look underneath it, it says SI units. This book will get you nowhere in life. So you cannot use this book. You have to use a book that has all of the units. Okay, so the edition that you use is not terribly important. But the fact it has to be Eunice Changel, and sometimes it's Changel and Bowles, just depending on when it's when it's produced. And it has to be in both SI and US customary units. So the reason I have this book is because a student got a really good deal on it. And he ordered it and got it and I found out it was unusable. So he gave it to me and I use it as a cautionary tale for everybody who came after. His name was Jay. So Jay does a good turn. All right. So I guess I should just finish up with I have to share this. Hang on a second. I'm going to share this window. All right. There we go. All right. So continuing, like I said, thermodynamics, the recommended text is the 8th edition. But if you want to use the 9th or 10th, even if you want to use the 7th or 6th, it is fine. But as it says, it must include problems in both SI and US customary units. And I can't translate for you. If you don't, the material in the textbook is not conducive if you get the SI text only. So don't get the SI text. I think I said that like 12 times, so you probably took my meaning. All right. The grading scale is going to look very familiar to you because it's a grading scale that I use in most of my engineering classes that do not have a significant lab component. Your homework will be worth 10%, your quizzes will be worth 10%, the midterm exam is worth 40, and the final is worth 40. Midterm and final are both proctored, so we'll be in this room. Quizzes are open everything, hope not open neighbor, but open all material that you have access to. And the homework is also self-graded and or self-done, self-paced. And you can use, if you work together on your homework, I think that's super. I think as long as you don't let somebody be a freeloader, I think we talked about this last year, but no freeloading. Don't be nice, don't be that nice to people.
Yeah, cheese brain.
Yeah. No freeloading. All right, make them do their share. So when you start doing the homework, you may realize that we use a lot of tabular data. And when you think about taking a test and you might think to yourself, how will I have this tabular data if I can't use my book? Well, the answer is you have property tables. You will not have to purchase this. I have this. So when you take an exam, this will be available to you. And all of the data that we need that you'll learn how to use is in this. So you don't have to worry about, I will not make you memorize, the dew point of any particular fluid or the critical point of any particular fluid. So you will have access to all that material during your exams. Okay. The other thing is, if you get a more recent edition of the textbook, they will talk about software that will do property table calculations for you, and you're not allowed to use that. You have to use these, which are colloquially called the steam tables. Okay. Once again, going back to my thesis that steam is everything in thermodynamics, but the property tables or steam tables give you the data. So it will tell you you can use software. It will refer you to software. If you wish to use it on your homework, you will not be doing yourself a favor because I will not know, but you'll get to the exam and you will not be able to use it. So please refer to the tabular data. It's either in the tables or it's also in your textbooks. So you'll be able to access that both places. And I think I can put it up on the Moodle page. Okay. So aside from that, like we said, 90 to 100 is an A, 80 to 90 is a B, and so forth. A lot of engineering students, and I still get people even my age, who have a terrible reaction to thermodynamics. It was a very difficult course for a lot of people, and they have like PTSD nightmares about it. I really feel that Chengel's textbook really eliminates that. I mean, it's really taught in a very step-by-step, organized and methodical way. And I've not seen the trauma bonding between thermal students that I've seen with other textbooks. So if you start to have trouble, you will. I mean, it's tough material. But if you have a relative that says, oh, I took thermal and I died 5 times, you're not going to die 5 times. It's much better now. We just do a better job. So, and then you can just easy, and then they will hate you for the rest of your life. So, all right, so we have some things that we can do. All right, so now let's go back to our Moodle page and talk about how this class is going to work. Okay, so we will meet Tuesdays. No, I didn't want to share that one, sorry. I'm going to share the other one. Yeah, I'm gonna have to get rid of that, hang on. Sometimes this. Oh, did I get, oh, I know what I did. I have to go back here, right? I usually have 17 tabs open, so that's my bad. All right, let's share this screen. We'll talk about what happens for you guys to be ultimately successful in this class. Okay, so here we go. So the first thing is the material is divided into different pieces of information. This is introductory information, just all the stuff that you need. So for example, we have the syllabus, which we've just gone over, homework template, which just shows you the green paper, how to write out a problem. You guys are old hands at this, so I'm not worried about you on that. The thermodynamic property tables in both sets of units is right here. There is a little video here that you do not have to watch, but it's called the flipped classroom. And this was an innovative idea a decade ago of how we approach this class, which is it's flipped because instead of me delivering the material and then you working on it individually, I deliver the material through videos when you're not in class, and then we come back together to work on them in here. So it's just, that's why it's flipped. And you'll still be spending a great deal of time doing homework outside of class without me. But as you know, I'm here. I feel like I'm here all the time. People tell me they can't find me, but I do not know how because I feel like I live in this building for 16 weeks, but that's, if you can't find me, just set up a Calendly appointment or send me a text or an email and I'll make sure I'm available. All right. So what I have done is I wrote out a little schedule for each week before midterm. Okay. So we have the same, you'll recognize this pattern as well. We have 2 homework assignments followed by a quiz, 2 more homework assignments followed by the midterm. I've written down the weeks here, these kind of blended. This is week 1, which is 1/13 through 16. There should be a space here, so I'll go fix that. But 2, 3, 4, 5, 6, 7, and then midterm exam week is the 8th week of class. Okay, it doesn't have that on here. But basically, I've illuminated the videos that you need to watch because the videos are the lectures. So if you don't watch the videos, it means that you've missed class. Okay, so you have to watch the videos. That's where the content is for this particular course. Okay, so the first week you'll watch, and I'll show you how this works, 1A and 1B, and then the next week you have 2, 3, 3A, and so forth. And so before you take quiz number 1, you will have watched all of the videos up through 5B. Okay, the reason that I do A's and B's is sometimes they're too long, or sometimes I just realize that I have left out something that I really want to go into in great detail. So instead of making it video 6, it's still really part of video 5. So you just have to watch all of those videos. And I put up the relative weeks in order to do that, and then your homework. Okay, so the way that the material is organized, the first chapter takes us 2 calendar weeks, this and next. I'll get rid of this tab right here, but here's lecture 1B. So I guess really this is going to be lecture number 1. I don't know where A went to. We'll find out. If it's not here, I'll get rid of it. I'll change the schedule. But then we have thermal lecture 2, 3, 3A, and then we have the homework problems. So for example, when you click here, this just tells you a list of the problems that you have to do. Okay, and so I've circled the problems here. Now, even if you don't have exactly, you can do them directly from this, or if you have a different edition of the textbook, you can use those problem numbers instead of these problem numbers. Okay, but as long as you have an SI and US customary system textbook, you will get everything that you want to do. This this is another thing just to talk about a little bit. This is called a manometer, and a manometer is something that's used to measure pressure. Some people have trouble with manometry, like I would imagine if you're good with equipment, you're not going to have trouble with it. But I sketched one out and showed how these work, which may not make sense yet, but when you're working the problems, you'll see what we're talking about. So it's just a little extra for you. But the big thing, as usual, is submit. So you submit homework number 1, it'll be due next Friday, and there's that complete list of problems. Okay, so just as usual, submit. Make sure that everything's done on engineering paper. Make sure that you submit it as a PDF file. That's the best way for me, or I can take a JPEG. Cannot read anything off an iPhone. So if it's an HEIC, can't read it. So I think you guys already know that, but that's kind of the way it works. And then we'll move on to chapter 2. Got some more lectures, 4, 5, 5A, and 5B. There's the homework set and there's the homework. Then we have this little thing broken out for the quiz. You just read through here, write it on paper and submit it right here. Begin with chapter 3, submit, chapter 4, submit, and then we're ready for the midterm exam. Okay, so at this point, do you guys have any questions? All right.
Oh,
Yes.
are all of the homeworks posted just like that one you showed us with the
Yes.
problems there and circle?
Oh, I understand what you're asking me. That is a good question. I think so, or at least they may not be circled, but they do have, you do have the pages.
Okay.
And then if I didn't circle them, the real place to get the list is right here.
Okay.
Right there. Okay. And you'll notice that as we get a little bit further along, like in chapter 1, there's several problems. We start getting fewer and fewer problems because they're quite time consuming. So you kind of want to give yourself a little room to do that.
So we would just have the book, like just to read and learn from?
Yes, yes. And then if you have a different edition of the book, this is just a backup plan. You don't have to do this set of problems. You just have to do those numbers out of whatever edition of the text you have.
Okay.
But you can use the ones that I put up.
Okay.
If you wish, totally up to you. But if you're using, like, if you have the 7th edition of the book and you want to do the problems instead of those problems, you want to do these numbers out of the 7th edition, that's fine as well.
Okay.
But don't cherry pick, right? Don't do some from one and some from the other, because that you can miss a concept if you do that. And I don't want that to happen.
Okay.
All right. So everything is posted. There you go. There's some more steam. So anyway, everything is posted up to midterm. Everything is here. I have everything available beyond spring break, beyond the midterm exam. I've never had a student who needed to work ahead. But if you get to the point, if you are that person and you are going to work ahead, just let me know and I'll post the material for it. He said, no, I'm good. All right. So that would be my expectation, but I'm just saying, if that happened to happen, we can deal with that as well. All right. So any questions for me?
I don't have a book. Do you think I should get a book?
You should get a book.
Okay.
I don't know if I have an extra book or not.
I was gonna say, I know I got a book from you.
Yes, I have at least one extra book. If you wish to come over to my office right away, we'll go see if I have another book.
Okay.
But yeah, otherwise I think you'll want a book. But make sure, like I said, no side.
No, do you think they have it at the library?
I don't know, let me
Because I could
do
just check on
something.
that too.
There's a couple of different sources because they are very expensive. So anyway, I'm gonna answer that question, but I'm gonna turn off the recording before, because we're gonna play around and see what we can come up with. Okay, the first choice would be one in my office. The second choice would be where can we find one.
Okay.
So, all right, so that's it for today. I will post this to the page. I may email the link to you as well. I do all of my lectures on YouTube. We're supposed to use the system UJA, but I don't like it as well as I just like YouTube, because just more availability and so forth. So everything will be available, and you know where my office is, and you know how to get a hold of me. So those are the deals. So you'll want to start taking a look at chapter 1 as soon as you're able to. And then everything will be due next Friday, and we'll have one more meeting next Tuesday. So you can catch up with me if you have questions or problems, or if you need to get a hold of me between times, please do that as well. All right, that is it for today. Thank you guys very much.